Okay, I'm going to go ahead and get started. I got 54 slides in this presentation, so I do want to kind of try to be efficient with this. We are going to jam a lot of information here because I do want our teams to really understand all the aspects of both of our 3D laser scanning and our drone operations. Bear with me if I kind of fly through some of the more boring stuff, which is kind of the specifications on actual product or some of the details. I'm going to try and stay out of the weeds with some of that stuff, but I do think it's important for us to understand what our capabilities are, and I do want to focus more on the application side of things with regards to what our actual capabilities are. We will be providing a couple examples throughout the presentation, and I'm hoping there's a lot of value in that. With that being said, I'm hoping, let me see here. I did send out an email yesterday. They're kind of forwarded just a touch base with everybody. Hopefully everybody got a chance to click on one of these scanning example links. They will lead you to a browser-based little format here that you can kind of basically get your hands on and kind of touch and feel some of this data here. But also too attached was also some marketing material that Molly and her team put together with regards to our 3D scanning and drone services. So please check those out, please share them, and please use them as needed there. So did want to verify that. Okay, so getting back to the presentation here. Another thing here too, again, we are going to be showing project examples within this. We do want a lot of these projects are actually ongoing right now, so we do want to refrain from sharing this with anybody outside of IMEG. So if it's something that you're interested in, learning or getting your hands on down the road, just let us know, and we can help facilitate some of these examples and such. Okay, just kind of an overall agenda here on what I'm going to be covering. I'm just going to give a quick introduction to our actual team, myself, and then just a little overview on who all is helping and where some of this equipment is, and then we'll dive into the 3D scanning operations as well as our drone operations. I'll try to cover as much information as I can in the time we have here. I'm gonna try and keep it under an hour, so I'll try to be efficient here. As far as introduction, my name is Eric Vallejo. I am the director of our civil engineering squad. I've been with Mistman IMEG for over 14 years now. I love the outdoors. I'm a snowboard guy. I love pontoon boating and motorcycling. 2006, I was third place regional amateur salsa dancing champ. It wasn't because of me. It's because my wife made me look good. So just want to throw that out there. I'm also Part 107 FAA certified and land surveyor intern and civil 3D professional. This is our team. I definitely want to give a shout out to all of our scanning operation teams, our drone pilots, those who help kind of process and manage this data. A lot of our operations, whether it's our scanning and our drone operations, we're still a little bit new to it. Our Phoenix and St. Louis teams, they've been scanning for about a year now. Our QC team has been scanning for over 4 years now. And then, our pilots have varied experience, but just over this past year, we have logged over 80 scanning projects and then 100 flights with our drone team. It's because of these people here that have been willing to kind of help develop these operations, this program. They're a reason for a lot of our success and the reason that we're going to continue to grow these operations moving forward. So thank you guys, first and foremost. Also, I did want to kind of throw this list out here in case, or any instance, teams outside of these offices or outside of these regions are looking for a resource to kind of help them, whether it's, figuring out whether one of these applications is going to be ideal for a specific project that we're going to use. Of course, you can always contact me and I can help facilitate, getting you to the right person and whatnot moving forward. But thanks again to all these people listed here. So one of the things I kind of wanted to start with is just kind of the big picture overview on what's actually going on with the industry. This was the most this is the most recent BDC magazine that was just out this past October. What they did with this, one of the articles within here was actually a survey to a lot of the quote unquote AEC giants, asking for some input on, innovation, technology, how their firms were actually using, what some of their clients were actually looking for. One of the common things within this article was actually the use of 3D laser scanning, drones, and of course, rendering tools, VR, and such like that. I invite you guys to check it out, take a look at it. There's a link at the bottom of the page, but overwhelmingly, whether it's 3D laser scanning or drones, a lot of firms are moving towards this tech to help help supplement the design and doing what they're doing now with regards to their operations. They're seeing a lot of value with using scanning and using drones to help in design and to help their clients visualize actually what's going on with this. So again, this is just kind of meant to show where the industry is leading. Again, I just wanted to kind of share that with everybody, but please check it out. But definitely wanted to preface that with this presentation here. So first up, I'm going to go over our 3D laser scanning operation, equipment, and software. Again, I'm not going to get too much in the weeds with this, but I do want everybody to understand what our capabilities are. The FaroFocus S150, we have 3 of these scanners currently. One's in Rock Island, St. Louis, and Phoenix. Of course, the frequently asked question is how accurate, are these scanners? If you look on a spec sheet, Google it online, it's going to tell you it's up to 1 millimeter. And really, the real answer is it depends, right? So as you can see, the scan speed, this thing can scan 976,000 points a second. Depending how dense you want your data, depending on what the site conditions are, depending on the number of scans, control, targets, the density that you want in your data, the desired accuracy, that's going to be dependent on what the actual output is. So again, this is just one of the tools that we have kind of within our scanning capabilities. This particular scanner here is most ideal for indoor, so for MEP, ST type applications. This is our other scanner that we have. It's the Trimble SX10. This is a total station first, so those that are familiar with the survey world, this is a high accuracy gun. It's a 1 second gun. Again, it does have scanning capabilities on top of it. The advantage of this is we can use it for topographic surveys, and we can also scan on top of control and incorporate that control outside of the field. It's not as fast as the Faro, but again, it is a total station first, and it is ideal again for more outdoor application. This particular scanner is located in our Rock Island and our Ontario office. Both of these scanners do take high-res photos, and they will use those photos to colorize the point cloud. Another tool that we added to our arsenal here is this elevating tripod. This addition can allow us to go above ground or above ceilings and below ground. Our max height is 13 feet. So above ceiling tiles, within utility utility vaults or manholes or anything like that, we can also access above and below ground. Some of the typical software that we'll use with regards to the scanners, Faro has their own set of software that we use. Basically, the software is used the primary software seen is used to register the scans, and the other pieces of software kind of aid in modeling and sharing of scanning data. We do subscribe to these, so these are included in our subscription here. Once we register and process the data, the very next stop for this data is to go into Autodesk Recap. Recap is whether it's our scanning or our drone data that we collect, point cloud data. This is the primary and the desired format to get from point A to C. So depending on what our deliverables are, Recap's always going to be the middleman. Because we primarily use Autodesk products such as Revit, Civil 3D, InfraWorks, it translates well between all these applications. Also this different types of software, we can get into Navisworks, Enscape, and some other 3D modeling, rendering, VR, AR capability models as well. So Recap's kind of the controlling or the primary software used to get us to where we need to go there. Trimble Business Center is listed on here. That's primarily used by our survey team that can also generate surface data as well. Okay, so now what I'm going to get into here is kind of considerations into scanning, how our operation works, how to get something again from that point A to point C, actually primarily point A to point B. So when we look at scanning, one of the first things we obviously need to look at is planning. It's an important part of our scanning operations, of course, because the more prepared our teams are prior to showing up in the field, the more efficient they can be. Items such as floor plans, pictures, videos, anything that helps us understand, the actual site itself before we get out there is going to be super helpful. Of course, understanding the scope of the project is always going to be helpful too, right? So, what are we scanning, or what's the subject? Is it a full renovation, or are we looking at a specific detailed area? So it's important to understand what the focus is so we can gauge the size. Of course, in some instances too, depending on where we're working at, security and access and such are going to be, something we may need, maybe a hurdle that to get us into the building or whatnot. So if we need to get specific training, or if we need to get certified or badges to get into a building, we'll need to know that as well. Once we are in the field, there's still going to be some setup prior to actual scanning. One of the ways we do that is with actual control or targets. In some instances, they can just be paper targets. We also do have these little orbs. Those are basically used to kind of tie the scans together after the fact. So targets, the more targets we use, the less registration we have to do. That'll reduce the processing time at the back end. So good control, less processing time. And then after scanning, our team will verify the data, clean it up, and then we'll get it ready for the deliverables there. Okay, so again, getting a little deep in the weeds here, but again, I do want us to kind of understand. This page is meant to explain some of the control parameters of our scanners. Based on what the desired accuracy is, the time of day, on-site conditions, the time that we have to scan out in the field. These settings here will kind of help us fine tune how the scan is going to be performed in a timely manner, and be able to get the amount of data that we need for what the needs are of the client or internally. So just to kind of explain that a little bit further, this is just a brief example of the difference in settings and time. A higher resolution and a higher quality is going to give you a higher scan time, right? So if you really need 0.05 of an inch point every 30 feet, so that's going to be your grid, it's going to take over a couple hours. Now, in those times that you see there are going to be without actual photographs being taken out in the field. So you can pretty much double that if photos are going to be taken in the field. And what that does is that what those photos will do is help colorize that point cloud. If we don't take photos, you're going to get a black and white point cloud. So the question here is that when we understand is what's overkill, what's just enough, but again, that goes back to understanding what type of data and how we're going to model the data in the point cloud that we're going to receive. Okay, with regards to deliverables, we have a few different options, right? So first and foremost, depending on who's asking for the scan. So if it's working internally, obviously we understand what we're getting, we understand what we need, we understand what the output is. If it's a potential client or an architect or an outside source that is requesting our scanning services, we need to understand what that actual deliverable is. So again, in most instances, or in all instances, most instances, we are our spot after scanning, our product after scanning is going to be a point cloud or an RCP file. There's been some clients that's all they want. Give us the photos, give us a colorized point cloud. We'll take it from here, right? So if we understand that ahead of time, again, it'll help us kind of price some of this stuff out. Now, the next step, obviously, we can take it into we could take it into a 3D modeling world. I'm not a Revit guy by any means, but can we model within Revit? Yes. Andy McCombs has been working closely with our QC standing team and he's helped us put quite a few models together. Andy, you're on the call. Do you mind speaking on a couple of the capabilities and/or considerations that our team needs to think about?
Can you hear me?
Yeah.
Okay. The density of the point cloud when modeling is somewhat important, just to analyze the data properly, identify it properly, and full coverage as well. So when they're going out to the field and setting up their scanner, just know that they'll probably need a lot of coverage to really get the detail that's needed for modeling. Modeling also was a lot harder in the past. We literally traced the point cloud. Now we have the Faro software that helps along the lines of identifying what's in the point cloud, so we don't have to necessarily trace it as much. It actually identifies pipes, ducts, a lot of that, conduits, a lot of that stuff. We do have to create, in the picture you see now, we did have to create family content as well. But again, that software helps with that. We can isolate equipment that's in the point cloud so that we can create those families. So
awesome. Thanks, Andy. Yeah. So again, just to rehash, it's important for us to understand when we go out, if we are going to build a model like this, and this is the deliverable, it will be dependent on how we scan out in the field. And then some of the Faro software we do have, it will recognize, some of these shapes and objects and will help somewhat model it for them. But there is still some setup on the back end as well. Thanks, Andy. Our other deliverable, of course, especially with our civil teams, is AutoCAD and Civil 3D. So in some one of the items that our QC team is increasingly doing is scanning for topographic surveys. The workflow is ideal in areas such as busy intersections, intricate sites where, for example, buildings where there's nooks and crannies everywhere. And then that goes onto the structural component of things too, is, if we need to tie in additional building onto it, or in one instance, we scanned for a skywalk to go into the 5th story of a parking garage. Something like that would be an ideal for scanning. Another application we use on the civil side, of course, is as-bills. Of course, so our guys are out at the I-74 bridge. We scan some of the columns going up there to verify that they're as-built. So again, this just another application, another way that we can deliver this product. again, we can also get it out to Enscape. We can get it into Navisworks. We can use it in VR, AR application and models as well. Okay, so getting into some of the applications that we've actually done. We're just going to kind of show a couple examples here. Of course, basically, if we can see it, we can scan it. So pretty much anything that you can imagine us scanning, or anything you would consider you would need measurements for, that'd be an ideal application. Again, the indoor stuff, the indoor applications is going to be more, it's going to be more suited for our Faro scanner. And then our more civil structural outdoor applications are going to be more suited for our SX10 stuff. But again, depending on where we're at, it's going to depend on what tool we use. But again, if we need it measured, it may be ideal to scan. So a few different applications that we've used this on. This is obviously a manufacturing facility here in Illinois. I believe the scope of this project was to aid in layout and make way for additional equipment going through. This is an example of getting some scan data information above a ceiling tile. Again, using some of the equipment, the tripods that we use. This is basically shows our versatility on how we can access different areas. This scan here is for Central Corners down at Phoenix. This is a simple shell space for a new surgical center, approximately 5,700 feet. This was performed by our Phoenix team. Jason Hawking, are you here?
Yes, I am. Can you hear me?
Yeah. Do you mind sharing a little bit about this project here?
No, not at all. So this was a project our office was awarded for engineering services for a pain center and ambulatory surgery center located here in Phoenix. As Eric said, it's approximately 5,700 square feet, and that included 2 Class C operating rooms, clean and soiled rooms, a pre-op, post-op area, a waiting room, medical air vac room, medical gas room, offices, and other support areas. When we scanned this, it was basically just a shell space, and the scan was able to identify that the existing columns shown in the architectural model were actually off by 18 inches. So when the architects loaded in the point cloud that we sent them, which was an E57 file, they use ArchiCAD, so the E57 point cloud file was compatible with ArchiCAD. But when they brought that in, they were able to discover that the columns were actually off by 18 inches and realized that they based their model off of existing drawings that were outdated. And so without the scan, I think this project could have, experienced some change orders, or, the architect would have had to reprogram some spaces, and it also could have affected the construction schedule.
Awesome. Thanks, Jason.
No problem.
Next one you guys did too here. This is a rooftop condensing unit up top, El Cajon. Do you mind giving a couple words here?
No. This one, this was another highly congested area that we have to go into, and this is for U.S. Bank in California, and it was a renovation project to an existing mechanical room and outdoor. Well, the one that you have there, Eric,
Mm-hmm.
this, just looking at those photos, that scan was actually for another U.S. Bank project. That is not El Cajon.
Whoops. Sorry about that.
No, this one was a study that we did for U.S. Bank project, and this was in it's another project in California,
Oh,
and this one was for Carlsbad, exactly. And so we went up there and we did a quick scan just to kind of show the owner what they had, and we were able to just kind of identify where everything was, and down to the unit size, curb size, and the screening. And I think they were able to give that information to, I think it was a mechanical contractor, and then they were able to kind of identify what they wanted to do with that project. But we just gave them the scan, and that was really about it. We didn't do any design services for that.
This is
This is El Cajon. Yeah, this is the one that we did. And like I said, the scope included is 1,400 square foot of a renovation to an existing mechanical room and outdoor condensing unit. The outdoor condensing unit, as you can see, it's located in a well, and so it's pretty challenging to get exact dimensions in there. But we used the scan to identify exact dimensions, location of equipment, and ductwork, just to assist us in the design process. And the existing drawings that were given to us to use as reference were obviously outdated, as they were the original drawings that dated back, I think it was 1974. And as we all know, the drawings did not reflect actual site conditions. So the scan actually, it helped us quite a bit in determining, like I said, where everything was in that mechanical room and out in that condensing yard.
awesome. Yeah, and you can see that, and so yeah, back to that. You can see these are the paper targets, and then some of these orbs that we set up. Those help those are our control and help tie these scans together. So if you see those, that's what those are. Thanks, Jason. I appreciate it.
Yeah, no problem.
All right. So this is an example of a boiler plant upgrade in Eastern Illinois. Kate Dennis, St. Louis. You mind giving a spiel on this here?
Yeah, sure.
Awesome.
So the owner had an existing boiler plant that was pretty old, and they wanted to consider a couple different options for upgrading or replacing some of the equipment, but the existing drawings were pretty poor, and there was quite a bit of piping that would have taken us days, if not weeks, to get right by hand. But over the course of a day, we were able to scan the entire building and get some detail that was really important. Yeah.
Awesome.
We took about 37 scans total, and we only took a couple color scans as well. We found that we usually didn't need the color as much as we thought we would, but yeah, saved a lot of time and a lot of money.
Yep. Yeah, and I'm assuming some of the black. I'm assuming some of the black and white was just obviously the color scans, like I mentioned before, take quite a bit longer. They definitely increase the time of the scan. So sometimes eliminating the photos will kind of help you be more efficient and maybe get into areas where or do a lot more scanning if you got a specific amount of time there.
Right. We usually did a color scan if there was an area that we knew was really tight, or maybe we wanted to see a little bit more detail later on, just to make sure that we had everything correct. But mostly didn't need it.
Awesome. Cool. Thanks, Kate.
Mhm.
All right. This here is another recent example here. This is a topographic survey we did out at Vandenberg Air Force Base out in California. This was performed by our QC and California survey crews. QC team, you want to speak on this real quick?
Yeah, Eric, this is John Lindquist. I got Jeff Wilt and Scott Misfelt. They were actually out on site collecting the data. It was actually just a traditional topo survey that we were doing, but the guys had some pretty complicated areas where they could use the SX10 to scan and collect that data that I could in turn use to basically make our topo a little more detailed. There was an area where there was a wall that the guys couldn't access because it was not safe. So they could scan it, and I was able to model that wall from the scan rather than putting our guys in a dangerous position. So one more thing about that project was we had a meeting with the client, and there was an area that was outside of the original scope that they just kind of needed a rough idea of what the terrain was doing. And they asked if we could provide any information on that. And so since we took those scans just kind of for our own benefit, it was nice to bring that out during that meeting and say, yeah, we have information that was actually beyond the scope of our work. So sometimes there's benefits to this data that you don't even know until it arises. The scopes change all the time on these projects, so it worked
Awesome.
out well for us.
Awesome. And then I did want to kind of show this example here too. This not on the slide, but this was this was what our scanning teams. I was fortunate enough to join our scanning teams out in Walla Walla, Washington. A place so nice they named it twice here just this past week or whatnot. But this is a scan of most of the site. Again, this was supplement. We were out there doing a topographic survey, so a lot of this data is supplemental. But one of the main reasons we decided to scan a lot of these areas was because of the number of buildings and structures on the site. Again, just like John mentioned, this helps us. This helps complete the data. And helps us really make sure that we have everything that we need to move forward. Again, if they're planning on building additions or improvements on the site, this helps fill in the blanks in case we miss something or the client or the scope gets bigger. And in some instances, that's always the case. I shouldn't say some. So thank you guys for sharing that.
All right, this is Mike. I just got a quick question. Are
Sure.
the pictures look fuzzy, or is it my computer?
No, you're looking. So yeah, good question, Mike. What you guys are looking at is actual point cloud data.
Okay.
Let me go back. I'll go back to a recent example here. That's a good question. I'm glad you brought that up. Let me open up this example here. So what you're seeing is actual point cloud data. If you actually look into one of these orbs here, this here is a photograph. So you're looking at a photograph now from the actual scan. So it's essentially a 3D dome image.
Okay.
So it takes these photographs, and then I'm going to kind of back out into this 3D view, and then it actually colorizes this point cloud. So yes, you're correct. Yeah, the examples you're seeing here are just point cloud based.
Okay.
But again, I do want to, it is important to note that there is high res imagery that's getting taken along with this, and it's essentially a 360 dome image.
And these points that are being collected, taken pictures of, they can be transferred over into Revit and produce an as-built
You got
condition.
it.
Yeah. Okay.
You got it. Absolutely. All this. Yeah. It's all this data is. We can translate it into Revit, into AutoCAD, Civil 3D. We can do many different formats. So good question. So yeah, this is kind of an example, right, of taking our initial point cloud and then going into Revit. So perfect timing, Mike. So with this, what you're seeing here is the original scan of this water tower here. A model was built using Revit, and then you can see the final product here. So this project here, what we're looking at was used to basically primarily calculate the surface area to plan for paint. So just a different type of application here. Okay, so a little bit, so just kind of going into some cost and value of this thing. All right, so, of course, the primary factors, when we're kind of assessing, if we're asked to put a proposal together specifically for scanning services, right? What's our traveling time? Again, I mentioned before, what's our available resources? If you were to request our scanning team for a scan, these are the questions that we're going to ask. Where is it at? Do we have any floor plans? Do we have any pictures? Do we have any videos? Give us all the information that we need prior to, so we understand and we're prepared and there's no surprises when we get out to the site. Understanding the scope is very important, right? Just like Andy mentioned before, how much detail do we actually need? How much detail do we need? Are we going to model this, on the back end? So that turns into, what do we want for cloud density? And then of course, what's our deliverables? Are we just simply providing a point cloud file, an AutoCAD file, a 3D model, VR, AR, what's going on next? So again, planning time, once we get out in the field, on average, typically, a scan might take, 5 to 10 minutes, right? So if it's going to take 100 scans, you can roughly calculate the time that it's going to take to do that. And then of course, processing inside the field, to get it to a recap file. Typically there might be 4 hours of processing for 8 hours of field. Again, recap, Revit, DWG, we can do it. In some instances, we will charge a base fee for the client as well. Okay. And then the value, and hopefully you guys heard that from our teams, right? We're reducing field time, right? We're eliminating hand measurements, and we're eliminating that error. Return trips. The amount of time you go back and forth. If your site, if it takes you a couple hours to drive to that site, that's 4 hours, round trip that you're going to be saving there from having to go out 3 different times because you didn't get enough information. Of course, all the data is highly accurate, and then we're increasing that visibility with regards to the 3-dimensional dome, and then being able to see everything around you. And then of course, either comparing it to as-built or using it for an as-built, moving forward. Okay. All right, so any questions on scanning? I'm going to switch over to drones. All right, so again, if feel free to after this to contact me or any of our team. We'll be happy to help you out, move forward with any projects. All right, so getting into the drone side of things. All right, so there's a lot of similarities actually between our drone and our scanning operations. Primarily, they can both produce a 3D point cloud. So just kind of diving in, I'm going to kind of get into, again, the same thing with our scanning. I'll get into our hardware, I'll get into our software, and then we'll kind of get into a couple examples and such. So this is our primary drone that we do utilize here. This is the Matrice 210. It's an industrial drone. It's very versatile. It's super stable. It's weather resistant. It does have a dual gimbal, and we can mount a gimbal on top of the camera for inspection. 50 miles an hour, 9 pounds. The biggest thing here is the battery life and the average flight time. Right now, the average battery that comes with these, a set, is going to give us about 15 minutes of flight time. So with any drone work or operations, it's very important that that we understand that we do quite a bit of planning up front to make sure when we get on the field, we're very efficient. Okay, so it does have some sensors on it, and then as far as this drone, we have one in Gurnee, one in Rock Island, and then one out west. Okay. We do have 3 different types of cameras, for the particular drone here. We have the X4S, which is a 20 megapixel 4K video camera. We have the XT2, which has a FLIR thermal sensor and a 12 megapixel camera. And then we have a Z30, which has a 30-time optical and a 6-time digital zoom on it. So I guess I've read a license plate at 300 yards with that zoom camera. So again, different tools that we have for different types of applications, depends on the project, on what we use moving forward. With some of the software we use to actually process and create our data. Primarily, we run everything through Pix4D. So if we're doing a map or an aerial image, or we're doing 3D modeling, this is a paid subscription that we use. It will essentially stitch the imagery together and create a 3D point cloud for us. The common file you're going to see is the recap. Recap, again, that's going to be when we go to point A to point C. Recap's always going to be our point B. Recap Pro, Recap Photo will help process and stitch the data together as well. InfraWorks is a piece of software that we use to kind of help conceptualize data, whether it's for master planning or conceptual design or anything like that. And then, of course, we take it into Civil 3D. We could use the point cloud in Revit. We can get it into GIS as well. And then, of course, if we're using thermal, if we're using the XT2, we have a subscription to FLIR tools that we can analyze data within as well. Okay, so again, with drone operations, there's a lot of planning involved because there's a lot of rules involved. We're up in the air, so we need to make sure that we're following the FAA because of federal regulations and such, and we don't want to get in trouble. So a lot of our drones have a registration number on them, and they have an IMEG sticker on them. So we always want to make sure that we're being safe. So typically with any flight, at the very minimum, FAA Part 107 certified person needs to be there. They're in charge of operations, whether they're operating the drone or they're a visual observer. Okay, so typically it's recommended 2 people out there, one keeping an eye on the drone, the other one handling the controls. But depending on the situation, that can certainly change. But again, safety is always first. Other items we need to consider is airspace, right? So project location is key to understand where that is. So we do register our drones with the FAA for insurance purposes. There are some geofencing security items that are there too. But with regards to airspace in general, we can only go about 400 feet above ground level. That's without any authorization. Once we get into controlled airspace, then there are some restrictions. So if we're near an airport, we need to know that. There's other airspaces outside of ANG that do include like temporary, military, trading routes. Wildfire areas is another one. Authorizations of waivers. So in specific airspace, we will need to get waivers or authorization to be within there. It's very important ahead of time that we have as much notification as possible, because those waivers can take anywhere from days to months to acquire. So it just depends on where you're at. Notification. In some instances, again, we always want to make sure that everybody understands what's going on. If we do get a waiver and we are around an airport, there's going to be some instances where we need to contact air traffic control. When we're flying near schools, hospitals, military bases or anything like that, we always want to inform security as well. So again, it's always important to notify so we don't get the cops called on us, or people don't think we're spying on them. Pre-flight considerations. Again, the project limits, the flight plan. Is it within controlled airspace? We need to account for security. We need to really understand what the limits are because of our battery life, right? Data storage. The bigger the site, the more data that we're going to collect. On our drones, there's a 64 gigabyte data card on it. So depending on how big of the data is, or big the site is, we need to make sure we have enough data to control that. Do we need horizontal vertical control? If we're doing 3D mapping with this, as opposed to 2D aerial image, we need to allow for time and get our survey teams out there to set control for that, especially if we're going to incorporate it or supplement a topographic survey or use it for boundary. Or are we just using it for inspection or marketing? So definitely stuff we need to understand before we go out to the site. And then of course, weather's always a factor. We're not going to fly it in rain. We're not going to fly it in a tornado. There's limits on what our capabilities are, and they are weather dependent. Okay, so some of the different type of applications are listed here. So again, another tool that we have in our toolbox here. What is the scope of our project? What are we trying to accomplish? What are our clients or our personal needs, expectations? Are we using this in aid in visualization? Is this a supplement to processing 3D data or a topography or anything like that? Is there a thermal application here? Is this for inspection? Are we going to include this in reporting? How are we going to use that data? It's there. Like I said, this what we have with the tools that we have are very versatile in the different applications that we can apply to this. So some of the different types of applications, proposal preparation, we can supplement visual imagery to proposals. One of the things we've tried is a proactive approach to understanding the project and scope to showcase capabilities, and as opposed to using a Google Earth image from 2013. Master planning, we can use an aerial image to overlay, as opposed to just simply 2D line work, right? So it adds a little bit more realism, it adds a little bit more vision to a plan, as opposed to just 2D line work on a paper drawing. Right? So imagery is stimulating, it can actually tell a story. Public presentation, community outreach, public meetings, social media, aiding getting support, from business owners or anything like that. So up on the upper right is a roadway project. This would be a better way to go to a client and say, hey, this is what the new road out in front of your business is going to look like. So just to kind of help others visualize what exactly we're going after here. 3D mapping and boundary survey, right? So we can get at the time of survey, we can understand the site a little bit better. Are there utilities on the ground? Is there paint out there? We can go out there, we can fly, we can understand where some of the manholes are, where some of these utilities and structures are. This again, just kind of supplemental to investigation out in the field. 3D mapping, of course, with topographic surveys, large open spaces. So areas where before we would hop on a 4-wheeler, GPS it, we may be able to get it with the drone. Boundary surveys, we've been helping out with there. We've been helping out there too as well with regards to Alta and land title surveys as well. Okay, so again, sometimes the actual imagery may tell more of a story than actual line work on paper. Okay, designing construction, right? So having that aerial image overlay, right? So if our civil team is designing a parking lot, and we only map to the middle of the road, it'd be nice to know if there was a driveway, where the driveways are across the street or maybe an adjacent road or something like that. Sometimes that aerial imagery overlay will help understand the big picture and extends beyond the scope of that topo. Weekly progress reports, inspection, such like that, where we can provide data and show progress. That's also another tool we've used it for. Again, aided inspection, stockpile volumetric analysis. Couple different projects. There's some stockpiles we've mapped, that are 50 feet tall. In Ottawa, we map the sand pits with drones. Those can be 200 feet tall. As John Lindquist mentioned earlier, with our scanning data and retaining walls, we don't want our survey crews up on these piles or on these walls or putting our guys in danger. We always want to think about safety. So from a safety standpoint, there's a lot of value to whether it's inspection or gathering data or replacing traditional methods with these new techniques and tools that we do have. Right, and then of course we get into record documents and then promotional marketing. Right, so as built, we can get a before and after photo, overlay initial design on top of it, structures, utilities, layout, such. We can also supplement to GIS databases and help with asset management, layers and such. And then of course we want to showcase our success. Proposals, qualification material, anything like that would be ideal for drone data. Getting into some of our infrared capabilities, power lines, transformers, substations, solar farms. So any of these electrical applications, we could utilize these, right? We can identify these hotspots to note any abnormalities or areas of concern. Okay, clearly you can see if something's not working right. that heat that it's generating will help visualize and isolate those areas. Building inspections, right? So we can identify items such as insulation defects, moisture, thermal bridging, items like that. Some other applications include, agricultural analysis. You can see there's a wind turbine example on there. You could see where it shows where there's cracking or defects. And then, of course, search and rescue. Not that we've done it before, but I hope to find Bigfoot. So those are some of our infrared applications there. Now getting into some considerations, value. Again, this is where we get a little bit similar to our scanning operations, right? Where's the site? What access do we have? If it's infrared, we need to think about the time of day that we need to fly. All right, what's going to produce our best results? What's the overall scope of the project? What are we actually trying to accomplish? And then, of course, what's our deliverables? Do we just want a simple aerial image? We after a video, or do we need to do a 3D map? All right, so depending on what that is, if we understand, the more we understand up front, the better that we can plan and be more successful. Cost to consider, again, pre-flight planning, being as prepared as we possibly can because our battery life is minimal. So yeah, for example, I flew Walla Walla, but it was close to, I think it was over 100 acres, but it took me 30 minutes of total flight time at 375 feet. So I had to, luckily there was an outlet outside. I was able to get it with all 3 sets of my batteries, but I was prepared. I was prepared to kind of extend that by having access to an outlet. But by understanding that ahead of time, what my actual scope was, it helped me prepare mentally and with my batteries and battery life and such. Again, processing, depending on the size of the site, it's gonna take longer to process. And then of course, just whatever our deliverables are, whatever we're trying to get, that time's just all based on whatever that scope of project is. So some of the values here, first and foremost, especially with the drone stuff, is safety. Again, there's a ton of applications. Whether it's even bridge inspection, if you think from that aspect. Even not having to rent equipment to get underneath the bridge. Maybe we can get up under there with a drone. And that goes into accessibility, efficiency, right? So I mapped a site. I flew a site in 30 minutes, more than 100 acres. So it's efficient. Is the data as accurate? No, but does it get the job done for what we need to do? Yes. Again, other factors, we can supplement our 3D mapping, increase our visibility, awareness, and then all the cool imagery that we get out of this, we could use it for different purposes. Okay, with that being said, that's it, folks. Any questions, comments, suggestions? I'm going to scroll back up to our contacts here. So I appreciate you guys taking the time here. I definitely, if you guys need to reach out, or if anything comes up, or if opportunities arise, or if you guys want to talk further after this, please feel free and feel comfortable reaching out to me. I love talking about this stuff because it's awesome. So hopefully we can help out all your teams, and hopefully we can provide a resource for all of IMEG, and we will continue to expand these operations. But of course it starts with making sure that we have the opportunities available to us to do this. Okay, so awesome. So unless anybody's got anything else, I'm going to leave it at that.